Now, find out the moment, which is the expected value for the discrete random variable and continuous random variable. So expected value is simply the summation of the, actually this is the expectation is the weighted average using the probability as a weight. So when we talk about the discrete random number, we have to add up because this is a weighted average of the our variable. Since this is a xk's expectation, and we calculated the k power to the x, and then probability over the x, and then we just add up. This is the calculation of expectation of k x power to the k. Right? For continuous case, we have to integral. Right? And here fx is PDF probability density function. And then we just add up. In continuous case, this is integral. So you can calculate the calculation, the integral, and then you will get a continuous random variable expectation. So yeah, as I explained in the last slide, low momentum is just x power to the k, and central momentum using, instead of x, we use x minus mu. So let's take a look at the Bernoulli cases. Bernoulli has two outcome, right? The outcome is just either 1 or 2, 1 or 0, so binary outcome, and then just we do the one trial. If we do this same thing as multiple trial, then that will become a binomial random number. So Bernoulli is the one try, and outcome will be binary, either 1 or 0, or only two possible outcomes. So first momentum is E over x, so we can calculate the mu, which is the mean. So we can get 1 or 0, and then what is the probability of getting 1 is this is x1 times this is the probability of 1, right? Plus x2 times probability of 2. That's the calculation of expectation. So 1 times 1 over 2 plus 0 times 1 over 2 is just 1 over 2, which is 0.5. Now, we can calculate the second central moment because that's our variance. So we can just simply calculate it. X is the x1 minus mu, which is the, we already calculated here, right? So this one is coming here. And then square, because it's a square, and then multiply probability 1, right? And then we do the same thing to the second one. x2, 0 is x2, minus, again, this is the mu, and square times probability 2, which is again 1. And if you calculate it, this is 0.25. So actually this is what? This is variance. But if you look at the Wikipedia, or probably you learn it from the previous statistics course, Bernoulli mean will be just P, which is the probability of success. Variance will be P times 1 minus P, which is the same. So we calculate this, and we calculate this, and we utilize moment, and then you can find our mean and variance using first moment and second central moment. Exponential. This is the example of the continuous case. So PDF looks like this. This is PDF. again, this is the one parameter distribution. Why is one parameter? Because I need only lambda, one number. Once I know the lambda, then I can create our PDF. So I can talk about all possible properties, right? So first moment will be calculated by x times PDF and then integral. So I will just replace this PDF here, then it will be this one. And then if you just use integral, why is integral is starting 0? This is minus infinity because the exponential just defined as this one. So minus infinity to the 0, there's all 0. So you don't have to, even though you do the integral, actually there's nothing. So that's why it becomes a 0 to infinity. And then here lambda is just coefficients is coming out, and then you can take derivatives, right? Here derivative is x times e to the minus lambda x. So when you take a derivative of this will be the x derivative times e minus lambda x plus x times e to the minus lambda x prime, right? So this one will become 1, so x will be gone, and then second one will be x remain, and then minus lambda will come down. Okay, so if you do that, then you will get a first moment is this one. So if you take a look at it, and then you have to utilize integral by part. So this is gonna be a pretty tedious or painful process, right? So therefore, yeah, this is about the derivative, but we have to do the integral, right? This is the derivative and this is integral. Actually, we use this fact. So here, so u v prime is u prime v plus u v prime. So if you want to take an integral of this one, right? So if you take an integral here, this integral will be if you take it out. Okay, I will clear this part. Yeah, I'm pretty sure you remember this. So if you want to calculate this part, uv prime equals integral uv prime minus integral u prime v, right? But this part, what is this? It's the integral and the prime, so it will become simply uv, and then this is u prime v. So that's why when you do this, you can utilize this formula, and then you can integral. But this is kind of tedious and then really painful. Do I have to do this complicated integral every time we calculate the moment? Is there any easier way? So that's why the moment generating function comes.